So hello everybody. Hello everyone. Welcome to the very first video of our Cambridge AS level statistics, that is 9707 series. Okay. So let's start with this. Imagine that I give you a data. Okay. So in this series, we will be doing about the very first chapter of our Cambridge series. Okay. That is the representation of data. So imagine that I give you a lot of data. A data like this thing. So what can you deduct from this data? Yes, a messy kind of numbers, which doesn't make any sense at that point. It's just a messy list. How do you quickly find out who scored the highest? Or how many passed? Or maybe somewhat like what the average scores looks like? Right? Or how do you think analysts in IPL calculate the strike rates from or the averages from thousands of balls? So basically, the statistics help us turn raw, confusing data and try to give us a clear picture so that we can see the trends, make comparison, and take better decisions. And that's what exactly we are going to learn today in the first chapter of our series, okay, which is known as the representation of data. Now, just talking about the representation of data, right? So, first we have to know, okay, so we will be learning about something about some basics, okay, of what is the data, right? How many types of data we have. So we will be covering some things like discrete data versus continuous data, why we need diagrams, stem and leaf, plot, box and whiskers, histograms, and cumulative curves. Okay, so this is the list of the things that we are going to cover in this particular video. Let's start with the basics of it. So first understand that there are two main types of data, right? Whenever we talk about data, so it's given that there are two main types of data. The first one is known as the qualitative data, and the second one is known as the quantitative data. Okay. Now, what is qualitative data? So basically, data, something like qualitative data is basically something which we say in words. Let's say the blood groups. Okay. So this is a kind of a qualitative data. Now, when we talk about this thing, okay, so it's just basically words. So we will not learn deep about this particular part. Okay, the example would be I would have given a blood group, right? Or let's say another type, I asked your favorite movie, something like that. Okay. The another type of data is known as a quantitative data. Now, what is a quantitative data? So basically, these are data which are represented by numbers. Now, it can be a large variety of data, but these data are represented by a numerical value. Okay. Now, the numerical values now can have two different sections. It can either be discrete or it can either be continuous. Now, this is the question. What does a discrete value means? So in general, okay, discrete values are values which, to be more precise, okay, it can be counted. Another word to say is it can be counted. And a continuous value, okay, it can have any values in a particular range which is given. So in general, a discrete value cannot be more precise. What it is, it is. For example, the number of pages in a book. This is the value of a discrete value. Example of a discrete value. Okay, if I say the number of words in a title, this is a discrete value. You can have fixed number of words, right? You can either have 7 words, 8 words, 15 words. You cannot say I have 15 and 3 by 4 words. Not possible, right? So these type of values are not possible in discrete. You may have fixed values. So generally it has whole numbers, but again, it doesn't mean that discrete cannot have non-whole values. Okay, it can have, in fact, non-integer values. Some examples are a famous example that of shoe sizes, right? The shoe size in UK, they have shoe sizes like 6, 6.5, right? 7, 7.5. No, but again, to be why it is discrete data? Because you cannot go between 7 and 7.5. Okay, so they have taken a non-integer value, but that is also fixed to a particular extent, right? Another example is how US is like dollar values are there. Okay, so dollar values are issued in 0.01. Okay, another value is $0.05. Another is $0.10, right? And it's so on. It can just go on, right? But we cannot say that we can have a $0.03, something like that. It has fixed values. That's another special case of a non-integer discrete value. Whereas when we come to continuous data, okay, so continuous data can take any value, okay, any possible value in that limited range. Okay, and that value can be as precise as possible, okay, depending on the factors. So let's just discuss about some examples of this continuous data. Some examples are time, a very important factor. So understand you are competing in a race, a 100-meter race, right? So I can have my like lap, okay, in like 7.52 seconds or even more precise, right? So I can track my things to seconds, to milliseconds, and even to a smallest fraction of that. One another age thing is age. When we talk about age, to be more precise, we are aging every minute, every second. Okay, so let's say if somebody asks how many years old you are, so you're 22 years, some months, some days, some minutes, some seconds, right? But age is a continuous data in that sense. Now, talking about this whole part, okay, now we talk about how to represent the data. So we have learned about this two data, discrete and continuous. There are different ways of actually representing these two data in such a way that we can represent the data in a much more familiar and understanding way. Let's just come back to the same thing that we were talking about. Okay, that was the scores. Okay, so if I just show you that scores again, at random scores, that doesn't make any sense, right? So what is a good way of this is first of all identify the data. This is a discrete data, right? So one of the way of representing discrete data, okay, is a stem and leaf. But before we start this all, okay, I wanted to show you a particular diagram which represents this all thing very beautifully. Okay. And this is what it is. So if we just understand this particular part, okay, so just revise this. This is qualitative data. Okay, in the qualitative data, we can have discrete data. Okay, discrete quantitative data. It can be grouped, it can be ungrouped. So for a small section, okay, we can have an ungrouped data, and it can be represented with a pictogram, a vertical line graph, a bar chart, a pie chart, a sectional bar chart. all of these topics we have already covered in our IG, right? Or O levels. We're talking about the grouped data. So in case of group data, we have divided it into two parts, a smaller group data and a larger group data. For a smaller group data, we always prefer a stem and leaf. Okay, now stem and leaf is a diagram that we will talk about just now. And for the larger amount of group data, it's again represented by two forms. It can be a histogram and can be a cumulative frequency graph. Okay, in case of continuous data, there are only two ways, the histogram and the CF graph. Okay, so I hope this clears the part of how we represent different type of data on different contexts, right? Now, coming back to the same part. Okay, so when we're talking about how to represent a particular data, so let's say this is the very first thing, right? This is all the data that we have. So first, in an stem and leaf, you have to identify, okay, what is your stem and what is your leaf, because it's a type of table which is best suited to represent a small amount of data. Okay, basically, you are seeing some data here. Okay, so the vertical lines are known as the stems. Because what we will do, we'll try to identify some numbers, okay, that are common. For example, you see a 75, okay, you see a 51, 28. Okay, so basically, I can see that this is 1, 2, 3, 4, 5, 6, 7, 8, and just see what is the last one. So that is 9. So this is 9. With this part, we understand that this is what a stem is. Now, what is a stem? It's basically a vertical line, okay, a vertical column that represents the group of data, right? And all the digits. Now, for example, if I take 1, okay, so I don't find a lot of numbers in 1. In fact, I don't find any numbers in 1, right? Here. So what we will do is we will keep it simple, okay? Now, we have one number here that is 8. And 1 that is 18. So this is the only number, and this is the lowest number in fact. So we will write this. Now, what we can do is while writing generally, right? We can always make a rough stem and leaf, and then we can arrange them. So let's say I'm making a rough stem and leaf here. But remember, stem and leaf is a diagram. So this practice is good when you are doing it for the first or second time. And when you're doing an exam, always try to make a rough diagram, and then you have to do it in between. So let's say I just completed, this is 75, this is 51, this is 28. Okay, and as you do it, go on cutting things so you don't get confused if the numbers are repeating. This is 67, this is 18, because the only one, the 67 again repeats, that means 67 is getting repeated. 39, 21. 32, 78. 29, 27. 74, 60. 53, 67. 89, 64. 92, 54. And 82 and 68. So basically, this is what we have. But is it the correct one? No. The thing is that in a stem and leaf, you arrange the number in the ascending order. In the leaf is arranged in ascending order. Also, it's a diagram. So it's very important that everything lies, like all the leaves lie one below the other in a very specific order. Okay? And let's say you forgot a leaf. Let's say I write here 1. Okay, I write here 8. Oh, and then I understand, oh, I just missed the 7. So can I insert the 7 in between? No, I cannot. So if you're writing it with a pen, so you have to erase the whole thing and write it. So better just complete the particular thing in a rough, then do it. Okay, or just if you did a mistake, make the whole figure again. So it's like 7, 8, 9. Now just observe in the third one, I'm just putting the numbers just one below the other. Okay, for the fourth one, this is only 7. Then there's 1, 4, and 3. The sixth one is, now we'll start with 0, 4, 7 is repeated 3 times, and this is 8. For the seventh one, it is 4, 5, and 8. And let's complete this with 2, 9, and 9. This is what my stem and leaf looks like. Okay, when I do this, this is a rough diagram, so we will just erase this particular part from here. And this is what my stem and leaf is. But there is a small problem here again. This is not the complete thing. It is very important to note that while you're doing the stem and leaf, you always have to represent something known as key. Now, what is key? Key is basically, if you just see this thing as a person, right, you don't understand what is this thing representing, right? So always include a key. Now, key is an example, like for example, I can tell in this case, okay, the moment I'm writing 3, 2, okay, I mean 32 marks. And now I just forgot to mention, these are the test scores, okay, for a given maths test. So 32 marks out of 100. Okay, so 32 marks in a maths test out of 100. Right? So try to be as specific as possible, okay? Because in AS, okay, this is very important. And if you don't write the key, you will lose the marks. Also, one more thing to understand is that in AS level, you may see back-to-back stem and leaf for comparison, okay? Uh, so the common mistakes, I will just again repeat it, is first, forgetting the key or not writing it properly. Second, unsorted leaves. So untidy leaves, you just insert a number in between, or the arrangement is not proper. Remember, it's a diagram. So the alignment should be very proper. And to draw it neatly. So even if you're doing with a pencil or a pen, please do it neatly. I don't want any rewriting out of it. If you feel the stem and leaf has went wrong, please cut it and do it again. Okay. Now, the second part is the box and the whiskers. Okay. So let's take this same data and move on it to understand what box and whiskers means by that. Okay. So for this particular data, the moment I see this data, I have to get some information out of it. Okay. Now, the moment I try to understand, I need some particular parts. That is Q1, Q2, Q3, and Q4. So let me just explain you this particular part. Okay. There are 5 Qs. This Q1, Q2, Q3, Q4, and Q5. Okay, this means, okay, the lowest number. This is the highest frequency. This is the median. This is the this is the lower quartile, and this is the upper quartile. So if you just see this particular thing, I hope you have done this particular part. Okay. In finding the box and whiskers, we can easily find out that my lowest is 18. Okay. My highest is 92. If I want to find the median, right, my median comes out to be somewhere around close to 60, right? And my interquartile range is 35.5. So that is indicating my lower quartile and the upper quartile at the time. This is what I got it at this point of time. Okay, so when I wanted to draw it, it would be something like this: an 18, 92, this is 35.5, this is 71, and this is 60. Kind of a box and whiskers that we need to form. Okay. Now, if you just want to interpret, the box plot shows a wild spread of data with the median closer to the upper quartile. That indicates that the graph is actually slightly negatively screwed. We will learn about the screwed data, what is meant by the screwed data in detail. Okay, but there are no outliers, and the variability among the students' score is relatively high. Okay, so that's it for this particular part. Now, just learn about the most technical one, okay, that I would like to discuss about here, okay, and that is known as the histogram. Okay. Now, whenever we try to actually find a data, right, there is a small difference between a histogram and a bar graph, and that is a very crucial one. So the thing is that unlike bar chart, there is no gaps between bars and a histogram because it's for continuous data. So you cannot have any gaps. Like a continuous data will take any value in that particular range as precise as possible. An important idea is when the widths are equal, but the widths are unequal, you cannot, the height of the class, okay, the height of the particular class doesn't represents the correct data. So in that sense, so that it doesn't create an illusion, okay, you have to take something known as frequency density. Okay, and that is important because then you can easily calculate what is the frequency per unit of data or per unit of area of that particular data, and that gives you a clear picture about it. Okay, now there are some exam rules that you have to remember for this. Okay, that is whenever you have a histogram, okay, you have to always label the axis properly with units. Use the pencil and scale for drawing the diagram. Remember, for any type of diagrams drawing, please use a pencil and scale. Make the graph and fill at least 3/4 of the space. So whatever the graph is provided in the paper, try to use 3/4 of the graph, not less than that. And never use raw frequency as height, okay, because the width differs. So even if the width is seems same to you, please find out the frequency density and write there in a different column, right down there. Okay, even if it's with calci paper, okay, you have to write that down. Okay, for example, you can see a solved example here. Okay, so it has shown particular graph that is being made, a scores of the students. Now, if you just see, the scores are different here, right? The difference of the first data, the class width of the first data, I would like to say, okay, is 19. The class width of the second data is 29. The class width of the third data is 19. And this is again different, it's 19. right? So this is different. One more important part is that since I told you that it should be that this at this particular point, it should be continuous data. So as you can see, this is not a continuous data. Okay. So the very first part that you have to do here is to make this data continuous data. How you will do this? So you will take this data like this. So it would now become 9.5 to 29.5. This will become 29.5 to 59.5. Again, this will become 59.5 to 79.5. And the last one will become 89.5, 79.5 to 99.5. Now this become as a continuous data because the data with your first class, the first class ends is the point where the second class starts. This is important to check always. If it is not, you have to make it. According to this, your data is now being calculated. So the moment we take the difference here, okay, it will become not 19, it's not 20. Because the class width is, I have to write the class width is 20. Okay, here it is 20. So again, and you can just calculate so on. Okay, so in this particular part, okay, when you have calculated the class width, okay, you can just divide the frequency by the class width and find out the frequency density. For example, for the first one, you got the frequency density of somewhere around 35, okay, and so on. And then you make this data. Some important parts to note down here is the first and the basic part is about a crank. So generally, we use crank when our data is not starting from the 0, but there is another way of doing this. That is, instead of doing a crank, you should start this with 16, and it's to start this with, let's say, whatever the number is. If you're starting with 0, it can be 0, like this. Okay, so this is 0, this is 16. That clearly resembles that the y-axis is starting from 0 and the x-axis is starting from 16. Another part of this, doing this thing, is that you could easily, you want to actually represent this not by frequency, but by frequency density. Here, clearly. Okay, and this is whatever the age is. So then we will write age in years. Okay, this data is actually of the previous one, which is shown above. But in this case, you can just have a look here. Next one to calculate the particular part. This is the formula for the frequency density. This is very important, and we will be using this formula frequently in the next few exercises. Right? Okay. Now, finally, we'll come back to the next part, that is the cumulative frequency curve or the CF curve, okay, against the upper class boundary. So some important things to note down here for this one. Now, we will do this particular thing, the cumulative frequency curve, in the next class in detail, and that's for it. Okay, so with this, let me tell in the comments, okay, which diagram do you find the trickiest, and the stemma leaf or the histogram, and what all representation of data have you learned or you recall from IG. If this helps, please like, share, and subscribe, and hit the bell icon. Share it with your classmates. I am Srish Nilmani, and I will see you in the next one. Keep practicing smart. You've got this. Bye-bye.